In this video, I will show you how to write a possible radical equation given the domain and the range. So keep in mind that the parent function for the square root function looks like this, y equals the square root of x, and if you were to graph that, it would look like this. Alright, starting from the origin and then curving in that direction. So if we spoke of the domain and the range, the domain would be 0 to infinity because the x values start at 0 and go to the right. The range would also be from 0 to infinity because the y values start from 0 and go up. Keep that in the back of your mind as we do this problem. So for part A, the domain is from 1 to infinity. Instead of being from 0 to infinity, it's 1 to infinity. That would happen if the graph were shifted over by 1 to the right. Alright, if I had a graph that looked like this, instead, that would have a domain of 1 to infinity. So I'm going to need a graph that is shifted over to the right by 1. On the other hand, the range is from 7 to infinity. That would happen if the graph were shifted up by 7. Alright, imagine that this is 7. And so imagine that the graph went like this. Alright, the range of this graph would be from 7 to infinity. The y values go from 7 to infinity. So we need a single graph that is both shifted to the right by 1, so we will have the correct domain, and shifted up by 7, so we will have the correct range. So we need to be right 1 and up 7. So we can do that if we have a graph that looks something like this. Okay, so imagine that we are to the right 1 and we are up 7. So that would be like this. This would have the correct domain and range. Now, if we want the graph to be shifted in that way, let's think about how that will make the equation look. If a graph is to be shifted to the right by 1, we need an x minus 1 under the radical. It's sort of the opposite of what you would normally think. Minus 1 is shifted to the right 1. If I want the graph to be shifted up 7 like this, I would need a plus 7 on the end. So this would give me the correct domain and range. So this is one answer to this question. Okay, what about part B? Now, we want the equation of a radical function with the domain negative infinity to 1 and the range from 7 to infinity. So what's this negative infinity to 1 business? Well, let's think about it. Just focus on that part. If I want the domain to be negative infinity to 1, okay, let's say this is 1 right here. That would happen if the graph were curving to the left instead of curving to the right. So now the domain would be negative infinity to 1. Okay, well, just like this. So because it starts from negative infinity and ends at 1. So we're going to need a graph that's facing to the left. Okay, and because we want the range to be from 7 to infinity, we will still need it to be shifted up. Okay, so let's see if we can make that happen. Okay, so we still need the graph to be shifted to the right by 1 because of this positive 1, and we still need the graph to be shifted up by 7 because the range involves this positive 7. So we know the end point is going to be right here. However, as we discussed we need this graph to be curving to the left. That way, the domain will be from negative infinity to 1. If I were to trace the domain on the x-axis, it would go from negative infinity to 1. That would be the shadow of this graph on the x-axis. The range would still be 7 to infinity in that order, because this graph still, the lowest value is 7, and then it goes up from there. Okay, so we need a graph that does this. So now let's talk about the equation that will make this happen. Okay, we need it to be shifted, focusing on the endpoint, it is shifted to the right by 1. So I'm going to need an x minus 1 under the radical. It's still shifted up by 7, so I will need a plus 7. But it's backwards, okay? This is reflected over the y-axis. All right, it's also shifted over to the right. That's why this is not actually the y-axis anymore. But whereas a normal, the parent function for square root curves to the right, if you reflect over the y-axis, then you get a graph that's curving to the left. So a left-facing graph is reflected over the y-axis. So how does that show up in an equation? A reflection over the y-axis is going to show up as a negative sign right here, a negative b value. You must have the parentheses for this to work properly. So this would be the equation that would have a range of 7 to infinity and a domain of negative infinity to 1. Okay, let's do that one more time. Now, again, we have, I see the domain involves a positive 1, and the range involves this positive 7. So when I set up my graph, I know the endpoint is still going to be shifted 1 to the right because the domain is an x value, and that endpoint is going to be shifted up 7 because the range, we were talking about y values, so positive 7 y value. So the endpoint is going to be right here. Now, which way is it going to be facing? So just focusing on the domain, we want it to be 1 to infinity, positive infinity. So that would happen if it was facing this way. It would also happen if it was facing this way, though. Okay? Either one of these versions will have a domain of 1 to infinity because it starts at 1 and it goes to the right. Which one of these am I going to choose? Well, we want the range to be from negative infinity to 7. The solid version up here has a range of 7 to positive infinity because it's going up. But this time I want the range to be negative infinity to 7. So I need it to be going down. So this is the version that I'm actually looking for. Okay, now when a graph is curving down like this, that is a reflection over the x-axis. Again, compared to the parent function, which looks like this. Alright, a graph that's curving downward is reflected over the x-axis. So keep in mind how this will show up in an equation. Okay, so once again, so here comes the equation. A reflection over the x-axis shows up as a negative sign in the front. Alright, as before, if we want it shifted to the right by 1, we need an x minus 1 under the radical. If we want it shifted up by 7, we need a plus 7 on the end. So the new part is this negative sign in the front. That's how we get a reflection over the x-axis. Alright, so this equation would have the domain and the range that we want. Alright, that's going to do it for this video. I hope it was helpful. I will see you on the next video.